Okay, so in our next video then, after we talked about kind of an intro to units, we ended our last set with some equalities. And that was in our metric system table. So these equalities would tell me like how many of one is in the other. So for example, we knew that there were things like 100 centimeters is the same thing as 1 meter. You can know that 1 millimeter is the same thing as 1 times 10 to the negative third meters. Some of these that we defined in our last video. So what I wanted to do today is take a look at some different measurements that we can take and then convert and how to convert between them. So we're going to break this down into two parts. We're going to break this down into non-temperature units. And then we're going to break it down into temperature units. So let's do a really common example. When we get to talking about gases, we're going to be talking about different units of pressure. And pressure was one of those really tricky things to measure. They have and we'll talk more about how that happened a little bit later on. But we ended up with a bunch of different scales. And so the standard unit is an atmosphere, which is the same thing as 1.01325 bar, which is the same thing as 760 millimeters of mercury, which is the same thing as 101,325 pascals, or it's the same thing as 101.325 kilopascals. And we can also see that an atmosphere is the same thing as 760 torr. So you'll notice that there are some pretty similar measurements here, and some similar digits, just with the decimal point moved around. So what we can do then is say, all right, well, if I'm given a unit of pressure, how can I figure this out? So let's say I measure, this is an example here, let's say I measure out, or I measure the pressure in a tire to be 1.39 atmospheres. How many pascals are in the tire? So in this case, what I'm going to do is I'm going to take a look at a technique called dimensional analysis. And in dimensional analysis, my goal is to use the units to cancel everything out. And the way that I'm going to do that is by looking at my list of equalities that we wrote over here in this box. So what my goal, I'm starting at atmospheres, my 1.39 atmospheres example, and I need to figure out how many pascals that is. Well, I know that there are 101,325 pascals in an atmosphere. So what we can do is just multiply by 1, or multiply by two things that are equal to each other. So what we can do is we can build a little bridge to help us bridge the connection. So when I bridge this connection, I know that 1 atmosphere is the same thing as 101,325 kilopascals. So just like in fractions, my goal is to get rid of the unit I don't want. So I want to get rid of atmospheres, and I want to keep pascals. So all I do is I use the equal sign that I was given to fill in the pieces of my bridge. This unit that I don't want is an atmosphere, and the unit I do want is the pascal. So I put the atmosphere piece on the bottom, and I put the pascal piece up top. What this allows me to do then is when I multiply through, I'll see that my atmosphere is on top and atmospheres are on the bottom. And you'll notice I have the same units in the top and the bottom of the fraction. So all I'm going to do is cancel that out and then finish off my math. If the numbers are up top, I multiply. If they're on the bottom of the bridge, I'll divide, just like in a regular fraction. So when I do the math, I multiply 1.39 by 101,325. And this gives me a final answer of 140,841 pascals. So let's look at a couple more examples. When I take a look at my some additional non-temperature units and non-temperature measurements, we can see pressure was a really common one that we're going to come up against. Let's take a look at some other metric system ones, maybe that were kind of new, to help reinforce some of those new quantities. Because you will be expected to know all of the metric prefixes and equalities that we talked about in our last video. So I strongly recommend copying down that chart from our last video to keep everything nice and organized for you. So let's take a look at a couple examples then. So in this case, a nurse needs to inject 1,500 microliters of antibiotic. How many liters is that? So in this case, I would have to pull up my use or my knowledge of microliters. Based on the table that we wrote, I know that 1 microliter is the same thing as 1 times 10 to the negative 6 liters. So what I'm going to do is I'm going to take what I'm given, my initial number, my 1,500 microliters, and I'm going to build a bridge that gets me to liters. So what I'm going to do is I'll see that my microliters is what I want to get rid of, and this is what I want to keep. So I have to put the microliters in the place that'll get rid of it. If it's up top and I place it in the bottom, they cancel each other out when we multiply through. So that means I put my 1 times 10 to the negative 6 liters in that top spot. And so when I multiply everything through together then, I end up with 1.5 times 10 to the negative 3 liters. You can also write this out in standard notation as 0.0015 liters. Both of these answers show the exact same number. It's just two different ways to write it. So let's do one more example together before we move on to our temperature unit conversions. So in this case, a veterinary technician weighs a dog in at 38.7 kilograms. How many grams is the dog's mass? So in this case, I want to go from kilograms to grams, and I know that 1 kilogram is the same thing as 1,000 grams. So I take my 38.7 kilograms, I build my bridge, my 1 kilogram goes on the bottom, and my 1,000 grams goes up top. And we'll see that my units cancel because they're in the top and the bottom, and I end up with 38,700 grams when I multiply everything together. So when we're doing this, remember the goal with our dimensional analysis is to use the units and equalities to get rid of the units you don't want. So the biggest thing that my students do is that they forget to write in the corresponding units and just try to throw the numbers together. So in this case, whenever you go fill everything, you'll notice I always wrote all my units out so I could see what would cancel. And whenever my units were the same, in both the top and the bottom of the fraction, or of the bridge, they canceled out. So this was just a little bit of an introduction on how to do our standard unit conversions. What we're going to do now is we're going to take a look at our temperature conversions. Because our temperature conversions are going to be based on two equations. I can either go from Fahrenheit to Celsius and back, or I can go from Celsius to Kelvin and back, but I can't go directly from Fahrenheit to Kelvin without some algebra. So I just like to keep the equations separate because math is a four-letter word for some of my students. So what we're going to do is we're going to give clear outlines as to what to do and how to do it. So in this case, if I'm going from Fahrenheit to Celsius, I know that the temperature in Fahrenheit is equal to 1.8 times the temperature in Celsius plus 32. And I know that the temperature in Kelvin is equal to the Celsius temperature plus 273. So these two equations are going to be really important. Be sure to keep these handy as you're tackling some of your dynamic study modules and chapter homeworks. So let's take a look at an example. A patient's temperature is 40.0 degrees Celsius. What is the temperature in Fahrenheit and in Kelvin? So let's find out. What we're going to do first is I'm going to write out my equation because it wants the temperature in Fahrenheit, so we'll write that in first. My equation is F equals 1.8 C plus 32. F for Fahrenheit, C for Celsius. And so what we're going to end up doing then is saying, all right, I'm given Celsius. So that means I plug this value in where the C is. And so when I do my math on this, I multiply 40 by 1.8 and add 32, and I see that my patient's temperature is 104 degrees Fahrenheit. That's pretty high. Good thing they came in to see you. So now we're going to take a look at what that temperature is in Kelvin. And so I know Kelvin is equal to Celsius plus 273. Since I'm given Celsius, I plug that value in, and I give my final answer of 313 Kelvin. So we found the temperature for both Fahrenheit and Kelvin by using those two equations. As we go through the rest of this chapter, we'll see that there are sometimes more complex steps when it comes to these unit conversions. So let's get a really solid foundation on how to do these 1 steps before we start moving to 2, 3, and 4 step conversions.